Good morning, everyone. I guess we'll get started. Probably there's a bunch of people going, I'm not going to make it to that. It's a little rainy outside. In fact, I actually looked at the radar at about 10 to 8 and I was like, man, I got to get out of here, otherwise I might not make it. Just so I can get an idea, how many of you, oh, you can't hear me? Is that better?
Yeah.
Okay. How many of you have heard of Raptor aircraft before? Jesus. How many haven't? Okay. How many have been following the video blog? How many haven't? Okay, so there's going to be a few.
Good marketing.
Obviously. Well, you guys have seen most of this stuff then. But anyway, I'll try and keep it interesting anyway. I'll give you some backstory on, what's been happening then. So just to kind of get you started on, how this all came about. This talk's going to be on what we've been doing for the last 12 months. So not so much the 2 years before that I spent designing the Raptor. So if you're hoping to see how I went about designing it, that'll be another talk some other time. Anyway, so let me get started here. So this, I'll give you a little brief start off on kind of how it evolved. What ended up happening was I was interested in building a Velocity, and I just couldn't afford to build the one that I wanted, and I wanted to build something that I thought might be capable one day of going all the way back to Australia. And so it was going to have a TSIO 550 and so it could fly high. It was going to have oxygen. It was going to have extended range tanks. And in the end, it was going to cost me about $250,000 to build it. And there was no way I could afford that. So, for years I just kept thinking, well, maybe I'll get there, maybe my business will pick up, because I'm a software engineer. I thought, well, maybe something will turn around and I'll be able to do that. But one day I had actually a bit of an inspiration. I thought, well, why don't I design the actual aircraft that I want, and we'll just see how it turns out. And actually I had the idea of having Velocity kind of build it as their next model. And so in 2013, at the end of Oshkosh, I said to them, hey, I'm going to go and design a new aircraft and we should build it. And they're like, okay. And they thought I was joking. So about a month later, I sent them a rendering just looking like this one, and they were blown away. And they started showing a bunch of interest. And I thought, well, this is going to happen. So I was working really, really hard on it. And after about a month, they kind of lost interest. And so I was already heavily invested in it. So I thought, well, I'll just keep going, because I had some spare time on my hands. And ultimately, I decided to take a little road trip and see if I could find the people who would be able to build it. And that's how I ended up getting involved with Jeff Curlow, and he was the one who had worked with Velocity before and helped them with their XL program, and also built several of his own aircraft. So he's who's working with me now as my main engineer, and well, he's basically the engineer doing all the actual physical work. And of course we have 4 other people working with us as well. But anyway, let's get back into this. So this is kind of one of the early renderings that I did, and this is when it was initially designed to have the Rolls-Royce engine in it. But that engine turns out was going to be super expensive, and it was going to be impossible to get and impossible to maintain, and we quickly just sort of got rid of it. And if you notice there, if you look at the tail of the aircraft there, you can see it's actually a little bit stubby compared to what it is now. So what ended up happening was I did some more redesign work, and after I met Jeff, he said, oh, you need to put a Pratt & Whitney engine in that. And I said, man, that thing's really long. And so I said, all right. Anyway, so I had to extend it about 15 inches, and I had to push the aft bulkhead forward a bunch as well, because I had to make about another 20 inches of space, Anyway, so these, again, early renderings, again, all done with SolidWorks. And this is, again, still, actually, I think this is with the Pratt & Whitney engine in there. And this is still with the other engine, so you can see it's kind of stubby in the back as well, but pretty much the same shape is still there right now. There's been changes to the winglets and the wings, and everything kind of moved and that sort of stuff, but the fuselage has maintained its same shape apart from the tail ever since the very start. So this is more of an accurate representation of what it was going to look like. And my goal here was to fix a whole bunch of problems that were in all the other aircraft. They were too small. They weren't very fast. They weren't very economical. They were super expensive, and they weren't exciting or sexy to look at. You know, so I wanted to try and address all those things at once because I didn't have anybody telling me that I couldn't do it. So here you can see on the side there how it was transforming when I put the Pratt & Whitney engine in there. So you can see how I had to stretch it out a little bit, and in the end I actually liked it because it kind of made it look better. One of the criteria that people say is good for a nice sleek body is a 3-to-1 ratio. So 3 times the length of the diameter of the fuselage is ideal. And you know, people have said to me, "Oh, that thing's big fat," but actually this is the most aerodynamic shape. And unfortunately, when I extended it, it ended up being about 3.5 to 1. So there's the overhead view, and again you can see how it was being extended out there in the tail. And this is with the Pratt & Whitney engine in there with the big fat exhaust on there. Of course, when I had this up on the website, I was again feeling out for everybody and saying, hey, you know, who's interested in this? And if you're interested, let me know, get on the mailing list. I want to know, you know, am I doing the right thing before, you know, I was going to spend any money on it. And there wasn't a lot of interest in there because, you know, who can afford to, you know, pay for a turboprop and then even run it or maintain it, or if something goes wrong, there's $500,000 out the door right there. So here's kind of a look, you know, with it rendered, showing everything kind of in carbon fiber, and this is much like how it actually will look if you were to pull the skin off, except for the, you know, the inside of the wings being blue there, they would be, you know, carbon fiber. And the inside of the cabin went through a whole bunch of different iterations. Initially I had like a single seat on one side, and then, you know, went to dual panels across the front there, but as you've seen from the video, it's wide. You know, I can tell the fish story. It's this wide because it actually is this wide in there. And this was a cool rendering. When I first put this up on the web, people were like, I haven't seen one flying. That one looks really nice. Can I buy that one? And I'm like, that's a rendering. They're like, no way. So this was with the 3 seats in the back. And again, even those seats there, they have you know, 20 inches across on the seat bottoms themselves. So it's much like a car. You'll have a little bit of, you know, you can see the corners of the headrests on the side ones. They're a little bit close to the windows, but you know, I didn't want to bulge out the back there around the head and compromise the aerodynamics. So there's my main sort of splash thing there that you're all familiar with, and I think it kind of sums it up, right? I think I got it right. This is actually still with the old 4-plane on there that was had a lot more sweep in it and has the winglets and stuff on it. But after I did a bunch more aerodynamic evaluations, I actually found out the 4-plane is just much better off if you just put a nice ellipsis on the tips there. Just less drag, and you're not creating any other issues. So what ended up happening was last year I was up here and I had a booth over right behind Icon there, and it was just a 40 by 40 grass thing, and I had a tent there, and I had another guy, Bernie, who was helping me with sales for the first year. And at the end of that show, I decided to kind of pull a trigger and start building it. So I made an offer to Jeff to come and work with me, and he accepted. So I immediately moved from California, where I was living and actually working at Capital One still as an Android developer. And we, you know, I moved out here. Jeff was already, out to Atlanta. And Jeff was already out there, and you know, so I was looking, you know, immediately from day one. You know, let's get a shop. Let's figure out how we're going to do this. We were going to go and get another guy to do all the CNC milling for us. The guy up in Illinois. He was going to charge us about $250,000 just to mill all these plugs, and I had no idea whether he was going to be able to even do it or not. And that was a big risk. So just on a whim, Jeff and I are sitting in Starbucks, and he said, you know, we could probably get our own CNC. I go, those things are like 250 million as well, you know, or yeah, 250,000 as well. And he said, well, let's just have a look, you know. So he got on there and had a look, and sure enough, we find this one on there, and it's sitting there as $90,000 for this CNC, and it looked like kind of what we wanted. The bed was a little short because it only had like a 10-foot bed on it. You know, we needed something to be able to mill about 16 feet, and we said, well, we could slide it along, you know, slide the work along and do it in 2 sections. So I said, well, let's just blowball them. So we put in an offer for $50,000, and they came back and they said, well, you got to put a little more in. So we said, all right, we kind of wanted it. So I offered him $70,000 and he took it. So next thing was we had to go out and check it out. So this is it when it was nice and clean, because they had gotten it. This was a CNC shop, and this was a real weird machine for them to have. They had all these enclosed machines, and they were doing all kinds of machining for different companies. And they had gotten this one because they thought they were going to create a whole bunch of statues or something like that. And they never used it. And it actually was operational when we got there. They made it sort of go around in a circle, and I'm like, well, it kind of looks like it works, but I mean, we never saw it mill anything, so we're still taking a chance. So we were the ones who had to actually dismantle it, and I didn't know anything about dismantling anything like this. And it looked, I mean, it's big. It's the top of that bridge there is about 10 foot tall, 11 foot tall, and it weighs a lot. So. And this is a control panel, my familiar friend that I'm standing in front of a lot. And this is with a forklift here. The guys actually in that shop help us dismantle it and load it up. But each of those rails there, have the stack on there. After you take the bridge off, you've got to load them up, sort of separately. So we hired a flatbed company to come and pick it up for us, and it was actually a pretty nice rig that guy had. The trailer cover slid back over everything, so we were pretty happy that it was going to be protected and stay dry. And then we had a little bit of time to check out Colorado, so we went up to the top behind Boulder there and spent like a half an hour, and it was, it's so nice. But at the time, all I was thinking in my head was, man, we got a lot of work to do. So we got it back. I got back into Atlanta. And I still didn't have a place to stay. I was staying in hotels. And we got back in at about 12 o'clock at night, and I had to drive back up to Canton where we got the shop. Actually, it's just outside of Canton. And it was about 1:30 in the morning, and the guy with the truck was arriving at 7, and I'm like, that's like 5 hours. I'm not gonna stay at like a $150 hotel for 5 hours. So I slummed it at the Motel 6. And got up early and got there. We had rented our own forklift and everything, and we unloaded ourselves, and without damaging it, we managed to put it together. But then, of course, the whole thing about leveling it and aligning it, and calibrating, and all that stuff still remained. So it actually took us about a month to get it all dialed in before we could actually even use it. In the meantime, we were actually starting to get stuff together. So I had talked to a company down in Norcross in Georgia there, and they had said that they were interested in doing an engine for us. So I just said, I'm going to send you an engine. I just bought one and sent it to them. So this is our engine, and you guys have already seen this. So it's a 3-liter Audi diesel engine out of a Q7 2014 model that had 8,000 miles on it, and it needs a bunch of stuff on it because when they pull it out of the car, they pull everything off. There's no turbo or anything. We didn't want the turbo anyway, so. And then here's the office we set up, and I just bought myself a $500 monitor there so I could actually work instead of working on my laptop here, and it worked out really nice for that. And we also were working on the model at the same time, so it wasn't like all we were doing was setting up the CNC. We're trying to get the model done as well. And we had to build tools, so I built that table, and I didn't even know how to weld when I built that, so it's not that great. It needs some more side bracing and stuff, and it needs to be leveled every now and then. And a lot of the stuff that comes off of it is not that level, but it doesn't matter because it's just platforms that we do. We're not building anything that is needs to be perfectly square or level. And then we had to get a compressor because you need a compressor in the shop, and we needed one big enough to run the machine as well, because the Z-axis goes up and down on a bed of air so the little drive motor doesn't have to lift it up and down. So we needed that, and then we had to get that all set up. And finally, we got the machine set up, and here you can see. I guess the sound's not going through there, but there's not really much to hear there. So I just ran a quick little pattern to make it move the various different axes, and at the time I thought that was the coolest thing. And as you can see, we haven't got the table set up or anything like that yet. The table that came with it is a vacuum table. It's designed to actually just put things on, and you turn the vacuum on, and there's all these holes in this, even when you put the littlest thing on, it just sucks it on there. But you know, with what we're doing, we just clamp everything on because the vacuum runs a lot of power. It's just not necessary for us. So this is the first thing that I milled, and you know, just created a platform, bunch of foam on there, and this was supposed to be the door skins for the top of the actual doors, because to me it was one of the simplest things that I could do. And we created that mold and everything that you've probably seen before, but we're not actually going to use it because I don't trust it. Back then, everything wasn't calibrated very well, and those door skins will probably come out and have a little bit of, you know, misshape, and the amount of time it takes us now to create a new mold is only a couple of days, so it's not worth risking it with using that one. But I'll show you just quickly where that's milling. I'm not sure how to get the sound over there. You get the idea. So this is when you do milling, you do a roughing cut like that, so you just basically everything's vertical. You cut out most of the stuff that's in the way, and then you can actually start doing face cuts on things. So again, this is just doing a roughing cut. So our engine, in the meantime, sat at this guy's shop for 2 months, and I was calling him every week and saying, when are you starting on it? And he's all, tomorrow. And he never did. And he finally said, I've got another guy for you who's going to do it. He really wants to do it. I'm all, okay. So he put me onto that guy, and I went and met with that guy, and he started actually doing some work on it, but he was worse because he did a little bit of work and kind of like waved a carrot in front of my face, like, yeah, I'm going to do it, I'm going to do it. I got a little bit done, see? And every day that I spoke to him, I was sort of thinking, oh, he's going to do it. I just need faith, you know? And it just dragged on and on and on, and finally, and I didn't have anybody else to actually work on it, so finally I actually found the guy who was going to do the radiator for us. He said, that guy you got doing the engine's not the right guy. I said, well, thanks for telling me. And he's like, I can help you, and this other guy, we can help you. So those guys have got the engine now, and they're actually making good progress. So we will get the engine going with enough time to have it running on the stand for a couple months and being able to run it every day, and you know, make sure it's not going to have too many problems before we even bolt it up to the prototype. So meanwhile, we had the model, and we have that flying a couple times, and we've had some problems with low-speed handling, mainly because of the way I designed the transition from the wingtips to the winglets. If you look at all the velocities out there, and the cozies and easies and stuff like that, they all have basically a straight-down hanging winglet, and in combination with having the borderlines that are these little, you know, things that hang down below the leading edge of the wing, and they stop these span-wise flows. So we've since put those on. But we haven't had a chance to test it yet, because when you go out to the field like that, it's basically a half-day trip out there, and I've been like really pushing us to try and get the fuselage finished before the show, so I could show everybody, look what we've done. And we only just got that done, so if we had gone to mess with this for even a half a day, we would have missed that, and then I would have been really disappointed. So anyway, we're going to be flying that again soon, just to test that we've sorted out the slow speed handling on it, but actually it flies really great when, you know, once it's in cruise, it climbs beautifully. I'm not having any problems with it. I mean, I was more concerned that the wider fuselage was going to cause some serious problems, you know, for the size of what it is. And the only problem that it has caused is a little bit of yaw instability, and we've already sort of fixed most of that by increasing the size of the winglets there. Other than that, you know, Jeff seems to think, you know, Jeff's flown tons and tons of models, and he says it flies great once it's cruising along, and, you know, obviously climb out and stuff. So we'll get that sorted out, and you'll see that in the video soon. This is when we first started milling the fuselage, and, you know, I won't run that through there. It's the same type of thing, but I said to Jeff, you know, what should we mill next? And he's like, why don't you just mill the fuselage? I said, well, can I work my way up a little bit? Because I'd done the little one, it was about this big, and then he's all, just do the big one, and oh, that's the low, you know, it's big, and it's going to take a long time, what if I mess it up? So anyway, went ahead and did it, and actually, it turns out now that it was slightly over milled, because back when we were first running the machine, I wasn't as accurate with doing all my measurements and everything as what I am now. So the fuselage plug ended up being slightly smaller than it needs to be, but fortunately for us, because it's just a lower fuselage, when we put the upper on it, we just let it expand out a little bit, at the seam, and everything fit fine. It was only out by a quarter of an inch, you know, mainly at the back there. So it didn't take much for us to figure out a solution to that. But you know, those are the things that when we see that, I'm like, oh god, now what are we going to do? Have to mill that again? But we have actually been really lucky, and things are fitting together really well. So this is further along now, you know, milling the fuselage, and I remember looking back and seeing how rough it was, because the machine wasn't calibrated at all. Anytime it went transitioning from one side back to the other, you could watch the actual end, and especially when you had the long mill in there, the amount of movement that it had that you didn't want to be in there, it was like it was doing a little dance around before it came back again. And I actually had to hunt around in all the settings, the FANUC settings in the software, just to see if I could find something that looked like I could change and it would make a difference. And I managed to find a bunch of these acceleration settings in there. And I started just playing with ones for each of the different axes, and I managed to get some results. And after getting the results, I was like, I think I know how I can get this dialed in. I managed to get it dialed in really well. And it was funny because the guy from FANUC came out, and he had his laptop there, and he had this really detailed manual that he had on there. I said, oh, can I get that? He's like, yeah, you have to pay. It's like about $350. And so after he left, I just Googled it, and sure enough, it was online, and got what I needed. We have a deal with them. You know, we pay them a contract for yearly stuff, so if something goes wrong, so it's not like they haven't got any money out of this. They're doing fine. So this is the fuselage after we had milled it, and then what we end up doing is just give it a light sanding on the edges, and we cover it with a one layer of fiberglass, and that protects the foam for when we spray the putty on it, because the putty actually goes on hot, and if you didn't do that, it would just melt. And this is the forward bulkhead, just after it's been milled, the foam. And here we are, this is the first time Jeff's spraying the putty here, and we didn't know how much this was going to off-gas or anything like that, or how much it was going to smell, and everybody was set up, you know, like we were going into a hazmat situation. And now we just have a fan that blows out the back, and Jeff's just spraying it, you know, with no mask or anything, because, I mean, you can't smell it, it goes out, you know. But we're in a building where there's we have a neighbor that is a dry cleaning and, you know, restoration company, and they have people's clothes and stuff in there. And the first day after we sprayed this, because we didn't have the fan going, she came over and she went ballistic. She's like, is this going to happen every week? And we're all, yeah, yep. So we've got to do something. It reeks in my place. So anyway, we sorted it out with the exhaust fan, and it's not a problem anymore. But anyway, this putty is called spray core, and you spray it on in a layer at a time. You let it sort of set a little bit, and you don't want to spray it on too thick because it sort of gets really hot. And when it gets really hot, it can still melt the foam underneath. Of course, then everything's not solid enough. So anyway, Jeff did a whole bunch of these things all at once. So of course, after that, I had a bunch of things to mill. And this was the first time milling the fuselage. So you can see there, again, I was still using the long mill, mainly because of the flange was so long. When it's down low, you can't reach across the flange unless you have a long end mill on there. So this one is 12 inches long, but it's not ideal for doing something like that, because you know, the longer it is, the more inaccuracy there is by the end if it's slightly out of calibration. So we also had to build other things, and this is a table that we built for allowing us to sort of roll fabrics and things out. And again, just built out of plywood. So it wasn't all about building the aircraft. In the early days, it seemed like about half the time was spent building tools or setting something up or whatever. And I was looking at kind of, are we going to start building a plane at some point? And everybody else was looking to the early videos. People were like, I've seen a lot of milling of plugs. I don't see anything that even looks like an airplane. There's a boat. So this is after we milled the fuselage. Jeff spraying it with primer. And of course, in the meantime, I've got a guy who's our structural engineer, does all the FEA analysis, and I basically throw anything and everything at him that is to do with the engineering side of things. Because I did the design, but I don't know anything about making it, you know, strong enough to actually, you know, handle the loads that we're doing. So I said to him as well, okay, here's my conceptual design for the belt drive. I want you to do the full design for it. And this was his initial one, and we had just a single belt on there. And I said, I'd like to have 2 belts on there. And he said, well, you don't need it. It's strong enough to handle all the horsepower you've got. I said, well, you know, pilots like redundancy. So, and he, you know, he's not a pilot, but he's done plenty of aircraft before, and he should have known that. So, anyway, so we got another belt on there now and managed to fit it in. And one of the problems that you have when you're doing a gear reduction or even a belt reduction is vibration transference from the prop to the engine and back. So, you know, we had to try and figure that out, and a little bit of Googling, and we found this guy. And so Siemens creates this one, and there's a bunch of different ones out there. It's a torsional damper, and so the center section there is kind of like a polyurethane type thing or whatever, obviously with cog belts, cog teeth there. And it's designed to handle vibration and also misalignment, and it's also designed to blow out if there's a major, you know, difference in force on it. So if you had a prop strike in there, that thing would just blow out and would be a fairly easy replacement. Probably wouldn't have to do anything to your engine. It'd probably be fine. So here's the fuselage, sprayed it with the top coat, and this was, I think, only the first time we used this blue top coat, and it was actually really difficult to sand. We ended up switching to a black one, and ultimately when I said to Jeff, you know, do we really need to use this top coat thing? Can we move things along a little quicker? And finally he's like, yeah, okay, all right. So now we don't actually spray anything with top coat. We just get them in the primer, because the primer we use is actually pretty hard anyway. And you know, as soon as we get them in the primer and waxed, we pull the mold off them, and then we put them into storage. So we, you know, we're probably going to pull some additional molds off some of the plugs anyway. The ones that we need where they take longer to lay out, so that we're keeping all the plugs. This is the nose, or the front of the train, if you want to look at it that way. And again, you see a little big dent in the side there, and that was where I ran the machine into it accidentally when I set up the tool path and didn't realize it was going to have a collision. But stuff like that, you just fill it over before you glass it. And there's Jeff spraying that one with the putty. So again, it gets 3 layers of that putty, and we end up, how we end up doing this is we overmill the foam by 3/16 of an inch. And so it's, you know, actually smaller, and then we add the fiberglass, which adds just a little bit more, and then we add about 1/4 inch of putty on there. And so when we mill it, we're only milling a little bit of putty back off, and we're leaving, you know, probably 1/8 of an inch of putty on the surface there. So other stuff we had to do, we needed a vacuum setup because we're going to be doing, you know, vacuum bagging of our parts in the molds. So, you know, Jeff picked this up on eBay, and as soon as it came in the door, he painted it. I didn't even have a chance to get it before it was painted. So it literally arrived. I was in the shop and I came out and it was painted. I'm like, where's that green thing that just came in the door? He's like, there it is. Oh, I wanted a picture of it. Anyway, so he got that all dialed in and hooked up in all the hoses. Of course, you know, Jeff's done all this before, so it's just great having him on board because he knows exactly what he's doing. It's just like just watching a machine go through the processes. Oh, actually, let me show you this video so you can see. So there's the hookup. Again, that motor looks brand new, but that was off of eBay as well, and he painted that as well. And you know, there's all the hoses, and there's, you know, he welded up the stand for it and put all those all the different fittings together. And I think we've used about 2 of the hoses off of there so far, but it's designed to handle, you know, 8 at a time. And how it actually works is you fire it up and starts drawing vacuum, and it stores the vacuum in that tank. So the minute you plug it in, you don't have to have the motor starting and drawing vacuum. It just uses off the tank. So actually, it's a nice system, you know, for doing what we're trying to do. This is that door frame thing, and of course we did the mold for that in carbon fiber. We didn't really need to do that, but I wanted to see, you know, how it was going to work, and everybody wanted to see some carbon fiber, so that's what we did. And you can see there, we're just pretty simple. It was just a flat surface, really. So we went down a bunch of layers, and I believe, no, we didn't vacuum bag that one. Just wet it down, and then it was done. So. Oh, actually, sorry, you're right, we did vacuum bag that one. And since then, we haven't really vacuum bagged any of our molds. It's not necessary. There's the nose again, and this was just so you can kind of see how it's finished with the indentation for the opening for the nose compartment door. And then some of the other parts there, those are basically just after they've been off the machine and they've been primed so they can get sanded. And in the meantime, it gets cold in Atlanta. That's my car out the back, and I was working late one night and it was snowing, And I was just thinking about, man, I can't wait to get to Oshkosh where it's nice and warm. And now I'm like, I can't wait to get back to Atlanta where it'll be cooler later. And of course, you know, it was snowing on a Saturday when I was in there working away. There's the nose in the black top coat. Ready, just about ready to pull a mold off of that. Well, actually, it still needed the final sanding on there and waxing. So in the meantime, I was still figuring out, you know, all the other stuff with the engine, and here we are with the belt drive set up with the engine just again configured conceptually, and the radiator is that sort of white block there above it, just, you know, to the left of it there. And then we had to create a jig for the fuselage and have it so we could put it up on the machine and use the machine to help align everything. Just makes it easier, you know, to get things nice and accurate. And then this is creating the actual cradle for the grid, for the jig, so just a fiberglass, and then that dropped into place, aligned it, and we, you know, used some epoxy to bond it into place there. And then we finally laid up the fuselage mold, and I was like, well, finally we're doing something. And this is, I don't know, I think this was January or something like that. So it took a while to sort of get to actually create the first actual mold. And then, you know, we had to create braces for it, so it just seems like there's always something more that needs to be done before you actually finish something. But, you know, finally when we popped it out, it was beautiful, and didn't have any problems with it, and, you know, nice and happy about that. And I was like, well, there's one of the big ones out of the way. And that was actually, I think, one of the first ones that we actually created, apart from the one that you saw earlier. And there it is from a different perspective. You can see it, you know, we had to put wheels on it so you could move it around, because it's not, you know, light. It's actually, you know, it's about that thick all the way through, a little bit more than 1/4 inch. And this is the overhead console, laid up, ready to actually have the mold pulled off of it. So that's the plug itself. And this is laying up the forward bulkhead. And Jeff was just really mad at me because I made this way too complicated, because I didn't know. I thought, you can just bend carbon fiber around anywhere, can't you? Apparently not. So we're going to change this, and because what I had done, I created a channel in there for the spar for the the foreplane to sit in, thinking that it was going to make it all stronger. It just made it more complicated. We didn't need it. So I've actually already designed a new one that'll be in the customer aircraft. And this is, you know, the problem with this is it's too complex. There's too many hard points, and then you see Jeff's got a piece of FR4 in his hands, and it's 1/2 inch thick. And it's solid fiberglass and resin, and it weighs a ton. I mean, it's really solid and it's good for bolting too, but it's really heavy and it adds so much more weight to the part. So we're not going to be, you know, putting so much in the new one. So this was the finished product when it popped out, and you know, it looks pretty nice and, you know, shiny there and that. But that's not what we're really going for. All those edges will have to be roughed up again because we're going to be bonding around the flange there. So generally, you don't really want to go for the shiny finish like that unless it's something that you specifically want to put on there. So we put peel ply on most of the things, but this was coming out of the inside of the mold, so you're going to get a shiny finish. You don't have a choice. And then we decided to put it in place just to make sure it fit, because this was the first time we were actually checking to see that one piece fit into another piece, and I was pretty excited to see that it pretty much fit. This is laying up the fuselage, and well, we already had it laid up, and then it's under vacuum, and it didn't take us actually that long to lay that up, but again, we did it in a couple of stages, because we laid it up first, and then we put the core in and re-vacuumed it, and then we put the final coat in and re-vacuumed it. But probably what we'll end up doing in the customer aircraft is maybe using an infusion setup where we put everything in at once and just run the infusion through. It'll take a little bit longer to set it up, but the part will come out in one hit. And there's the vacuum pump going. You can see it's pulling about 24 PSI of vacuum on there. And that kind of fluctuates between about 29 and 23, and then it'll kick back on and pull more vacuum. So here's the part for the fuselage once we had it finished. And how it works is Jeff runs around with this little wedge that is hooked up to the big fat air hose that we have, and you sort of slide the wedge in underneath and it pushes air under there, and then you sort of, you know, if you need to, you get the rubber mallet out there and help it release. The molds are waxed up a lot, so you know it'll release fairly easily, but it doesn't, you know, always work exactly as planned. And this one was interesting because we were running around there and we were shooting all this air under there and we had no idea what was going on. It turned out we created this massive static charge underneath the whole thing, and we had no idea it was there. And I was the first one to get hit. I had my fingers under the front of it, and I basically put my fingers under the front of it, and I felt like I had about 220 volts hit me, and I was like, whoa! And I was looking around and wondering if the guys had thought I was freaking out or something, and they couldn't figure out why. And I didn't know what to say. I wasn't sure if that's what had happened yet. I thought I'd kind of imagined it for some reason. And next to a sudden, one of the other guys got hit too, and he's like, and I think it was actually Jeff got hit. He's like, oh yeah! And then one of the other guys got hit as well. And then I think we were actually, grab something metal and see if we could ground it. So we were looking for a bit of like aluminum or metal that we could actually sort of touch to it and touch it to the floor. And everybody's saying, well, I'm not touching it. So it took a little while before we were brave enough, and finally we got it out, but it was fun. So this is, you see Jeff basically walking around. He's got the wedge there. Puts it under there and hooks up the hose to it and just blows air under it. And, you know, once you get it sort of lifted, you put a bunch more wedges all the way around, and just sort of to keep it up, and eventually it will pop. But you know, there's the little door openings there. There's these little sort of negative areas that could catch, and you know, sometimes it just gets sticky under there. So it can take a little while to pop them out. Anyway, you don't see it popped out in that one, but here it is, popped out. And of course, it had the white top coat sprayed in there before we had it. And even there, you kind of look at it and you think, oh, that'll make a nice boat. And so that was our fallback plan. If the aircraft didn't work out, we'd get into the boat business. Just had to put a transom on the back and we'd be all good. So here we are, got a couple of bulkheads in place, forward bulkhead and aft bulkhead. So it's starting to look a little bit like something. And in the meantime, sort of side projects are always ongoing. So this is a stand that I designed and sent off to our guy Mark, that we're going to be able to bolt the engine to. And I designed it so it has the same slope on it as what our finished firewall is going to have. So when we get the engine mount, we bolt it up to the engine, we'll be able to bolt it up to this, and this will be kind of like a straight up mock-up of what the aircraft will look like in the back. So once we get it all dialed in, we'll just unbolt the engine mount from this and bolt it right up to the aircraft and hook up the connections, and everything should be fine. It's not like we're going to have to try and figure it out on the aircraft itself. So that way we'll be able to keep working on the aircraft over here and not be distracted by somebody working on the engine off to the side. This is another one with the nose. This is after the mold got laid up. You can see there all the peel ply that's over the top there. And again, we put that on. I think this one we did in 2 layers or 2 go-arounds, I believe. Yes, most of them we basically put the black top coat on there. Have to wait for the first layer to dry, second layer of top coat on there, and then we put a layer of light fiberglass and 2 layers of lightweight carbon on top. And generally that's kind of the end of the day for a big part. And so we basically peel ply it in the morning, come back and pull the peel ply off, and then we put 4 layers of heavy carbon on it, and then it's finished. So we usually finish it in a half day, but lately the guys have been really picking up the pace, and they've been doing the smaller ones. They just do them all in one day, which is kind of nice. And then of course you have to create a brace for the larger ones, or even the smaller ones, partly to stop them from allowing to warp a little bit, but also giving them a stand to sit on, so when you're actually laying up, you're not rocking back and forth. And this is the one for the upper fuselage, and it just looks like a big, kind of like a skate ramp, I guess. And in the middle there's the channels for where the parachute straps are going to be. And here you can see we're just, this is actually the mold that came off the roof, and so we're just cleaning it up, pulling out the rubber profile that we put in there to create the vacuum bag channel that we're going to use later on. And then of course more braces for that. And and again, more side projects. So we already, a long time back, we'd already created the molds for the windows, and we'd sent those off to guys up in Ohio, and they were busy cutting the windows. And we'd always planned to create a fixture that we could actually vacuum the windows onto it and use the machine to trim around the edges and get a nice, accurate cut. So this is the sort of fixture that we created, and it looks a lot like all of our other things, basically designed to put the 4 windows on, not at the same time, but I wanted to make one fixture so we didn't have 4 different platforms there. And how it works is we have a channel there around the outside, and there's a vacuum hose that basically mates up to that channel, and we put a rubber seal around the edge there on the outside of that channel, and we put the acrylic glass on there, and then pull a vacuum, and it just sucks the glass on there, and we can trim it. So here's the upper fuselage one again, and this is where it's been finished. The braces are on the side, it's up on the wheels, so getting ready to be able to lay up that part, but we still had to do the door insets for that, so it was still a ways away before we could actually lay that one up. And here's the rear pressure bulkhead, and again, a little bit complicated on how it ended up being. There's all sorts of different weights of core that are in there, and the pieces of FR4, the green ones there, those are hard points for where the landing gear, the main landing gear axle is going to be, and the upper pivot for the scissor mechanism. So you need to have all those in there, and a little bit complicated, but in the end everything is necessary. You can't just sort of say I don't need that, or I got to get rid of that. You have to have it in there. So this one was obviously laid up, put the couple layers of carbon down, put the core down, put the layers over the top, and then you bag the whole thing and let it cure, and then you can release it and trim it. This is Jeff laying up the nose there, and you actually have to be very careful with this carbon fiber. You can pull it and skew it in all kinds of different directions, but ultimately when it lays down, it needs to be kind of its natural shape. You don't want to stretch it this way or stretch it this way, and you always sort of put it on a 45-degree angle so that once it's laid up, the fibers are actually following the longitudinal axis and lateral axis of the actual aircraft itself. And there's the nose popped out. Of course, again, Jeff used the white top coat on there, but obviously didn't need to spray it where we were going to cut out the door there. And here's just trimming it with the reciprocating saw. Just sort of trims it back and then sand it back to the edge. So all this stuff, just more and more work that has to be done on every one. But again, everything's necessary. And here we are with the windows. So this is the first aft window or rear window has actually already been milled, but you can kind of see it's still sitting on the fixture there with the vacuum still on. And here we are milling the windshield. So using a 1/4-inch bit that's specifically designed for cutting acrylic, and we're cutting it, and it's 1/2 inch thick acrylic. We're cutting 1/4 inch at a time. So do 2 passes on it, and then we decided to hold it in place, and that was pretty exciting because all of a sudden you can kind of see the fuselage really coming together. But then I said to myself, that's the last thing you're going to see until I actually have the cool one to show you with the upper fuselage on. So here's kind of the finished thing of that fixture, and it's with ultra suede, so that when we put the acrylic on there, it doesn't get scratched. And we've just put that in storage now, ready to cut the next set of windows when we're ready. So of course, again, something that took quite a while to create that thing, but now that we have it, it's really fast to cut the windows. And we're all about creating tools that make everything easier and quicker in the end. If we had to create like a routing mask or something like that for those things, you'd end up with not a very good result. And having that machine ended up being really godsend for us, because we're not only milling stuff, but we're doing all kinds of stuff on cutting the braces out of the foam, even though it's just a really simple thing. It's much faster for me to just whip it up on in the CAD and then create a quick toolpath and cut them out, and they fit beautifully. So here we are cutting the other rear window. and again, depending on what sort of material you're cutting with the machine, you use different feed rates or different speeds for the machine, and also different spindle speeds as well. So this is 10,000 RPM on the spindle, and I think it's moving at about 50 inches per minute. So it can take a little while to go around, but if you go any faster, the bit will get too hot and you might break it or something like that. And then we had to create a routing mask for what was going to be the upper fuselage, so it was going to be too difficult to use the machine to trim out the windows on the upper fuselage. So we created this routing mask by using the same mold for the upper fuselage, and then I actually used the machine to cut out the windows on this and just overcut them. So we run a router around there, and it actually cuts a little bit smaller than what you see there. So it was designed to cut out the rear windows, the front of the roof there, where the windshield is, and also the cutouts around the back and where the main spar goes through. And then here, this is the plug for the glare shield, and you see this one is ready to actually, or just about ready to have the mold pulled off of it, and we don't do the black anymore. So we saved ourselves a lot of time by not doing that, because it was much harder to sand and took a lot longer to do so, and we get the same result. And this is one of the door inserts that we created. So everybody's been looking at the door inserts going, how's that going to work? And Jeff and I were asking the same question. We weren't quite sure for quite a while, and we're like, okay, so it comes around to here, and then it interfaces here, and then how are we going to create this transition where the vacuum has to be and everything? It took us a long time to figure out. Jeff's done it before in his other aircraft, but he hasn't done it where the actual frame sort of hangs out below what you've done. So that added like another level of complexity, but we managed to do it, and it came out great. So this is just the insert. Obviously hasn't been trimmed or anything yet, and just taking out the vacuum channel there. And then this is the upper fuselage mold with the inserts bolted into place. And they actually fit beautifully. We were pretty happy about that. And we had put a channel in there to put a rubber seal around in the end. But when Jeff looked at it and they were fitting so well, he said, well, why don't I spray the top coat in there? That will seal around the edge anyway. We don't even need the rubber thing in there. So I'm like, well, if we don't need it, let's not use it. So we put it on there, and we put the vacuum on there. We had one little minor leak on there, and we fixed it very quickly. And other than that, it had pulled a good vacuum on there. And there's a layout for the glare shield, and this was just 2 layers of the heavy, I believe it was the heavy carbon that we used, and it ended up being 6 pounds. And Jeff sat it on the table and pushed on it like this, and it wouldn't even move. He goes, it's too strong, we've got to make it lighter, so we're going to make another one just with half the thickness, because there's still a couple of braces that support it as well, and we're trying to save weight wherever we can. So meanwhile, the engine, back to the engine, there's always something going on there. So we had this set up here, and this is with the turbo mounted in place, and if you see kind of right in the middle of the screen there's a sort of what looks like a shiny little object there. This was an adapter plate that we had to get specially milled, because the turbo that we're using doesn't have a built-in wastegate system, and it doesn't made up to the factory one that Audi has, where you have the oil inlet and an oil return. It only has an oil return coming out of the bottom of that turbo. The oil inlet's on the top. So we had Kyle mill up that adapter. And then Mark started working on the Y-pipe, and then realized fairly quickly that the Y-pipe was going to sort of join the 2 exhaust manifolds up to the inlet for the turbo, but there wasn't going to be enough space to actually have the outlet going to the wastegate. So he called me up and he said, I'm not sure how to do this. I think we need to lift the turbo up like 2 or 3 inches. And I said, oh, we'll be sticking out of the cowling. But then, of course, this is why I have the CAD stuff. I actually said, I'm going to come over to your shop tomorrow, and I came over there, because I didn't have an accurate location of where the turbo currently was, and once I got there, pulled a few measurements, put it back into the CAD model, I found out that we had about 3 inches of space to move it up still. So we decided to move it up 2 inches, and he's in the process now of doing all that. So probably next week I'm going to see some pictures of that where the Y-pipe is done, and you'll see the plumbing out there going to the wastegate, and ultimately, you know, with the exhaust system that we're putting in there, and anybody who's following along knows that I've actually designed and put a muffler in there, and specifically made it so the exhaust comes out the right-hand side of the aircraft. So if you're making left traffic at most airports, the sound's going to be going up instead of down. And I think this one having the exhaust going through the turbocharger, which, you know, acts as a muffler anyway, and then having quite a lot longer exhaust than most aircraft that just dump them straight out underneath, and having the muffler in there. The muffler will probably reduce the sound by about 15, possibly 20%. And it doesn't sound like a lot, but in decibels it actually makes a big difference. So this thing should be really quiet, and that's kind of what I'm going for. You know, I don't want to be annoying everybody with it, you know, coming in or departing. And here we are. This is the glare shield sort of mocked into place, and you can kind of get a feel now for how that's going to look. And you can see how horizontal it is there. I've designed it so anybody in any seating position, once they've adjusted the seat for themselves, they'll be able to see the outside edge of the windshield there. So the glare shield doesn't block your view at all. This is when we're laying up the upper fuselage, and when we actually created the braces for that, we made it so you could actually tip it on the side. So here it's tipped to one side, and it allows us to lay in all the stuff on the side without trying to crawl in it. So there you can see this is on the second go around. We already had the core put in place there, and you can see where we have the core for the straps for the parachute. And here it's under vacuum. So basically finished, and this was only a couple of weeks ago now. And finally we put it on. So it starts to look like an actual aircraft or something, not like your usual aircraft, because everybody says, wow, that thing's big. And you know, we've had a couple of people come by the shop, and I kind of discourage it, because when they come by, I don't want to be rude, and they're like, well, can I run around the back and peek in the door and see what? I said, just come through, have a look. And you know, they end up spending about an hour, and it wastes an hour of my time. And you know, they're standing there, well, so when are you going to get this thing flying? Well, when you leave, we'll be able to keep, you know, moving along. So there's another perspective there. Again, this was just last week on Thursday and Friday. We got all this in. The seats that we have in there, we borrowed from the Euro Auto parting shop that's across the other side of the highway from us. And they're out of a VW Phaeton that they parted out. And I called the guy up, and he's a bit of a friend of mine now, because I've been over there a bunch of times. And I said, can I borrow those Phaeton seats for a couple of days? And he said, oh, sure. I said, do I need to leave my credit card in case we damage them? He goes, oh, no, you're good, I don't need them. So we put those in there, and they actually looked a little bit small in there, which was kind of neat, because, you know, I'm actually going for a nice, comfortable cabin that's designed to be a lot like your regular SUV that you have, or your sport utility, or your pickup truck or whatever, and that's exactly, you know, where we ended up. So this is Keith, who's kind of, I wouldn't say he's an intern, he's just working over the summer for us, and he started with no experience, and behind him is Zach, and they're basically sitting in front. Well, Keith is 6'1", so you can kind of see how much room he has, and that seat's sitting a little bit lower than it needs to be. You know, for him, if he was to adjust that to the right seating position when we had everything dialed in, he would be sitting a little bit higher than that, and also a little bit further forward. But you can kind of get a feel for how much room there is, and it's kind of neat when you sit in there. It feels a bit like you're in the cockpit of a 747, because the windshield, you know, nicely raked forward, and you've got this big long glare shield. And, you know, once the panel's in there, you will have you know, 3 different screens there, G3X on either side, and a big like a 17-inch flat panel in the middle that you'll be able to run your iPad off of, or your Android off of. And then you can see I'm just moving the camera into the back there. And there's obviously no seats or anything in there. But I was able to lie down in there, and my head just touched the outer edge of the skin on one side, and my feet were flat on the other side. And I was only on a little bit of an angle. I'm just under 6 foot, so that tells you how wide it is in the back there. Obviously, once we have the door trims in there, it'll be a little bit less. But it's designed that when you have the 3-seat option in there, you'll have 3 seats. The bases of those reach 20 inches wide. So, and that's about the standard width of most car seats. So it won't be like a Cirrus where it's like 2 1/4 seats in the back.
Sorry about losing the last couple of minutes of the video there. My GoPro actually was full and I didn't realize it. Anyway, you didn't miss too much, just a couple of minutes and then the question and answer session. I appreciate you watching this, and keep following the weekly video updates. Thanks.